In the heart of a bustling metropolis, where neon lights danced with the city's heartbeat, lived a young girl named Clara. Clara wasn't your typical child, content with sidewalk games and playground chatter. She saw whispers of chaos in the city's rhythm, a hidden melody woven from countless threads of chance and consequence. One day, while exploring a dusty attic, Clara stumbled upon a curious contraption. It resembled a clock, yet instead of hands, it had a multitude of gears, each humming a different tune. A weathered inscription on the base read, "The Butterfly Effect Symphony." Intrigued, Clara wound the device. The gears whirred to life, their melodies intertwining, forming a discordant symphony. The narrator's voice rose above the cacophony. "This symphony, dear Clara, is a reflection of our world, a complex dance of cause and effect. Each gear represents a choice, a decision, a butterfly fluttering its wings in the grand tapestry of existence." Clara observed, mesmerized, as the gears, initially erratic, began to find harmony. Some sped up, others slowed, their rhythms adjusting to the others' melodies. See how their interactions create new patterns, unpredictable consequences rippling outward like ripples on a pond. A single gear, a seemingly insignificant choice, can change the entire symphony. Suddenly, the gears screeched to a halt. A tiny brass butterfly, perched on a gear, had lost its balance, disrupting the delicate balance. The city outside the attic window mirrored the chaos, traffic snarling, sirens wailing. "This, Clara, is the butterfly effect. A small action, like the flutter of a butterfly's wings, can trigger a cascade of unforeseen consequences." Clara, with newfound understanding, gently adjusted the butterfly. The gears whirred back to life, the symphony resuming, now richer, more complex. The city outside calmed, traffic flowing, sirens replaced by laughter. Complexity, Clara, is not a web of tangles, but a tapestry woven from countless threads. Each choice, each interaction, adds its own melody to the grand symphony. And we, like the gears, are not bound by predetermined paths, but free to dance with the rhythm, to create our own unique song in the ever-evolving symphony of life. Clara, her eyes filled with wonder, closed the attic door, carrying the melody of the Butterfly Effect Symphony in her heart. She knew that even the smallest choice could ripple through the world, composing a symphony of endless possibilities. Welcome, wanderer, to the heart of the fractal labyrinth, where the whispers of complexity theory dance with the echoes of ancient philosophical quandaries. Tonight, we delve into the labyrinth's depths, exploring the profound implications of a world woven from tangled threads of cause and effect, chance and determinism. Imagine a snowflake, a delicate masterpiece of ice, each intricate branch a testament to the intricate dance of temperature and pressure. Now, zoom in, deeper and deeper, until the snowflake becomes a labyrinth of its own, mirroring the larger structure in its smaller parts. This, my friends, is the essence of complexity, the infinite self-similarity, the endless fractal dance of patterns within patterns. What does this mean for our understanding of the universe? Does it shatter the comforting illusion of a clockwork world, where every action has a predetermined consequence? Or does it offer a new lens, through which to view the grand tapestry of existence, where free will and determinism coexist in a nuanced, ever-shifting dance? Think of a butterfly, its fragile wings fluttering in the breeze. Can we truly say its flight caused the distant storm, or was it merely a ripple in a vast ocean of preordained events? Complexity theory suggests a more intricate waltz. The butterfly's flight, a thread in the tapestry, interacts with countless other threads, weaving a symphony of unforeseen consequences. This challenges our notions of control, of absolute knowledge. We stand at the edge of the labyrinth, mesmerized by the mesmerizing patterns, yet forever unable to grasp the entirety. Is this a humbling truth, a reminder of our limitations in the face of the universe's vastness? Or is it a liberating realization, a call to embrace the unknown, to dance with the uncertainty, to navigate the labyrinth with curiosity and wonder? Perhaps the most profound philosophical ramification lies in the concept of emergence. From the swirling chaos of the Big Bang, galaxies, stars, planets, and eventually, life itself emerged, defying the simple sum of its parts. Consciousness, a symphony of neurons firing in a delicate dance, arises from the complex interplay of matter and energy, a testament to the universe's creativity, its capacity to surprise. So, wanderer, as you venture deeper into the fractal labyrinth, remember this: complexity is not chaos, but a hidden order, a symphony of interconnectedness. It is a call to embrace the wonder of the unknown, to dance with the shadows and the light, to see the universe not as a machine, but as a living, breathing tapestry, woven from the threads of chance and consequence, free will and determinism. Let the labyrinth guide you, not with answers, but with questions. Let it ignite your curiosity, your sense of wonder, and remind you that the greatest journey is not about reaching the destination, but about relishing the dance, the ever-evolving symphony of existence.
Imagine a single cell, a microscopic cosmos brimming with life. Within its intricate dance of molecules, a symphony of complexity unfolds. Proteins, the orchestra's conductors, guide chemical reactions, while gene sequences, the sheet music, dictate the cell's destiny. Yet, this microscopic stage is not isolated. It interacts with its environment, a web of other cells, exchanging nutrients and information, composing a grander symphony of life. This, my friends, is the essence of complexity theory, the study of systems with many interacting parts, where the whole is greater than the sum of its parts. It sheds light on phenomena that elude reductionism, revealing the hidden beauty in the intricate interactions between the simple and the vast. In the realm of physics, complexity theory challenges our understanding of order and chaos. It offers a lens to understand the swirling patterns of turbulent fluids, the intricate dance of particles in quantum systems, and even the birth and evolution of galaxies. The universe, once viewed as a clockwork mechanism, now emerges as a dynamic tapestry, where chance and determinism intertwine in a cosmic ballet. The implications for biology are equally profound. Complexity theory helps us understand how ecosystems evolve, how brains process information, and how diseases spread. It offers a framework to study the intricate web of life, from the rise of consciousness to the delicate balance of an ant colony. But complexity isn't just an observer's tool. It holds the key to unlocking the secrets of engineering and technology. From designing self-organizing robots to creating sustainable energy systems, complexity theory offers a roadmap for navigating the intricate dance of interconnectedness. So, as we delve deeper into the labyrinth of scientific inquiry, let us remember this: complexity is not a barrier, but a bridge. It bridges the gap between the microscopic and the macroscopic, the simple and the vast. It offers a symphony of possibilities, a tapestry woven from the threads of knowledge and wonder. Let the universe be our guide, not with answers, but with questions. Let us embrace the unknown, the emergent beauty of interconnectedness, and dance with the melody of complexity, unraveling the mysteries of our extraordinary universe, one thread at a time.